Hi there. Welcome in. Glad you could join us today. My name's Scott Fincher. I'm a data scientist on the evangelism team here at Knime. You may have seen me around. I taught some of our previous text processing courses a couple years ago. I'm also on the forum all the time. Maybe I've seen some of you there. At any rate, I wanted to go ahead and get us started with our webinar. If I could get my slides, there we go. This webinar is on state-of-the-art language models. So we've got a lot to tell you about that today. Let's go ahead and get it started. First of all, a few housekeeping things in case you haven't joined one of our webinars before. We'd like for you to interact with us using the live chat. If you click on the chat button, you can speak with other folks who are online. You can also go ahead and tell us where you're posting from. Right now, I'm actually in our Constance offices in Germany. Normally, I'm based out of Austin, Texas, but over here in Europe this week, be interested to see where some of you are posting from. And then apart from just chit chat, you also have the ability to ask questions via the Q&A tab. We hope you do ask questions. We'll have some of our own Knime folks online answering questions live as we go in the chat, and then we'll also select some of those questions at the end that we can answer live with our expert speakers here. So go ahead and type those in as we go. I will say one of the questions we always get is, will there be slides? Will there be recordings available? The answer to that is yes. You'll get an email from us after this is over pointing you to those resources. So don't worry about that. We'll make sure to make that available for you. Let me check real quickly to see where folks are posting from. I see someone from Sweden, sunny South Africa. So that's a bit of a long ways away from Sweden. We've also got some folks from Berlin, Brazil. Oh my goodness, Brazil, Malaysia. Excellent. So as always with our webinars, we have people participating from all over the world, and that's really great to see. Thanks everybody for checking in. One more bit of housekeeping here. If something goes wrong, sometimes that happens. You may just want to try a different web browser. Always, you can try refreshing your web browser, check your internet connection. You might try using a private tab. If you do have to refresh and come back, just make sure you click on the stage button right over here when you come back to rejoin the stream, and we'll be right here plugging away for you. Okay? So don't worry about any of that. Excellent. Well, before we get started, I wanted to go ahead and introduce today's speakers. We've got a couple of really interesting speakers for you today. The first that you'll be hearing from is Perttu Korhonen. Perttu has more than 15 years of experience in supervisory and macroprudential analysis. Currently, he's developing Qatar Financial Center Regulatory Authority's Vision 2030 for AI augmented supervision, and he's building a roadmap for digital transformation and leading a supervisory data science team there. So welcome, Pertu. Really glad that you could join us today.
Thank you, Scott. Really good to be here.
Excellent. We'll hear from Pertu in just a moment. I also want to introduce our other speaker, Artem Ryasik. His background is in life sciences. He has his PhD in biophysics, and he works as a data scientist at Redfield, one of Knime's partners. Has a lot of projects that he's working on. He works on graph analysis, recommendation engines, NLP, which we'll hear about today, of course, and data anonymization. When he's had some extra spare time, he works on Knime extensions that you may be familiar with, including our OrientDB and privacy notes. And then he also even teaches Knime courses sometimes in the Nordic countries. So really glad to have Artem with us today as well. Welcome.
Thank you for introduction, Scott. I'm really excited to demonstrate the NLP extensions we have been working for quite a long time together with Knime team. Thank you.
Excellent. I know you guys have been working really hard on it. It's exciting to see what they're able to do. So Artem will be back with us shortly to show us a demo of how these nodes work. Before we get into our speaker presentations, though, I did want to take just a minute to give a little bit of an introduction to Knime, because we always have folks that join these webinars that say, I'm interested in NLP or text processing. I don't really know anything about Knime, and that's okay. So just briefly, what is Knime? Knime is a complete analytics platform for all data workers. From soup to nuts, we start with data ingestion, take you all the way through blending your data, building models and visualizing, and ultimately deploying and managing. The way that we do this is through our open source analytics platform. It uses a visual GUI aspect that's really important. Drag and drop the nodes. The nodes are these little colored boxes that you see on the screen here. Each node does a task. So some nodes might read in PDF files. Other nodes might blend and concatenate data together. Yet other nodes might actually build predictive models. So we've got you covered all along the way. And if you'd like to be able to integrate Knime with, say, Python, um, write some Python code that you want to execute within Knime, or you can even write custom nodes using Python now. that's something we do as well. So since we're an open source tool, we want to play well with the other tools that the data science community is already using. The AI and ML libraries that we have present in Knime are really advanced. You can do, simpler things like build decision trees for classification and so on, but you can go all the way through devising deep learning networks using Knime as well. So we've really got you covered there. And then once you get into the production aspect of things, if you need distributed execution or cloud execution to throw more horsepower at really big data sets and the models you've been building, we can support there too. Whether you're building out REST APIs for people to use, where you want to build interactive data apps maybe, or maybe you just need to send a report on a monthly basis to someone, all of that stuff that you can do with Knime. So from soup to nuts, covering the entire data science cycle with this open source graphic GUI-based platform. So now that I've introduced Knime to you, and you'll see it later when Artem actually shows you on the screen how some of this stuff works, I want to talk a little bit about what Knime already is doing with text processing. So we have a text processing extension. We've had it for some time. And the nodes that we're going to talk about today are adding additional functionality. So what can we already do? Well, there's kind of a 5-step process that we go through when we're looking at text processing. First, you have to get the data into Knime. And so we have different nodes for reading in your PDFs, your tweets, maybe it's Word documents, flat files, whatever it is, getting that unstructured text data into Knime, several nodes available for that. Once we've got it into the software, then we're going to be usually enriching the data in some way. That might involve tagging. So let's say we need to tag based on sentiment. We want to assign words a positive or negative sentiment value. Or maybe we want to tag parts of speech, or maybe we want to tag name entities. These are all ways that we can add metadata to our unstructured text to be able to give it a little bit of structure so that we can process it in a more meaningful way down the line. Once we have, that's step 2 here, this little circle at the bottom. Step 3 is where we're going to start pre-processing our data, cleaning it up and reducing the feature space to make it more palatable for the models that we're going to build. So that might involve doing things like removing punctuation, making sure our case is consistent, stemming and lemmatization of words so that we don't have terms with duplicate meanings in the text. We kind of filter that down. All things that we want to do to reduce that feature space. And Knime has an extensive series of nodes that can help you do that. Once we have a nice, clean data set that's been boiled down a little bit, ultimately we need to translate it from human readable text into a mathematical representation, usually a sparse vector matrix. And we have some, document matrix nodes and things that will help you do that translation. Then once we're in the mathematical space, we can take a lot of different algorithms that are just kind of standard algorithms, maybe for clustering or classification, and build models. We'll see how we do that a little bit later on, or you can build a tag cloud, other visualizations that you might want to do for text processing. This is the general way that we approach text processing within Knime, something you can already do today. We've got a lot of resources to help you do that. Now, having said that, what we really want to talk about are the new Redfield capabilities that they've been working on extensively. So there's a couple of different extensions. The first is the BERT nodes extension that they've built and have added several nodes to recently. If you're not familiar with BERT, it stands for the Bidirectional Encoder Representations from Transformers Library. Say that 5 times fast. You're better than I am. Uh, it makes that library available in Knime. On the back end, it's using TensorFlow 2. And one of the really nice things about the way this is available in Knime is it can access GPU. So these models that you build for text processing can really put a lot of stress on your hardware. If you're using the GPU, that can help quite a bit. And so these nodes make that possible. The nodes that I have listed on this page here aren't all that are available. There are several more, but I just picked out a few to highlight. The first one that I have listed here is the BERT model selector that allows you to go read remotely pre-trained models from TensorFlow or Hugging Face through a drop-down selection. You can just go grab the model that you want. Knime will download it and bring it in locally. Or if you have a local model already on disk, you can select that too. And then you can feed that model into a BERT classification learner. This is going to take that pre-trained model and allow you to fine-tune it even more using, again, a graphical user interface to make those selections. You don't have to write any code to do this. Oh, hopefully I'm back there. It seems like I had a little glitch on my machine. And there we go. Hopefully I'm back and you can hear me. Now, the BERT embedder was another node that we have listed here. where that's going to allow you to convert text to vector form, kind of like doc2vec does or a spaCy vectorizer already does, but just in the BERT space. And then one of the really new stuff, or one of the new extensions that Redfield has provided here, are in the NLP nodes extension. And these are based on the spaCy library. These make that library available via Knime. Oh, thank you very much for confirming that I'm back. I was just going to go no matter what. The spaCy library is going to allow you to do these various pre-processing tasks. Again, the nodes listed here aren't the complete nodes in the extension. There are several more. But there's a tokenizer node, kind of like the existing Knime strings to document node. Instead, it uses a spaCy model to do the tokenization. There's a pre-trained model for named entity recognition that you can use. So you don't have to train the model like you currently do in Knime. You can just use theirs for picking out those persons, locations, and organizations. The limitizer node will convert the words to the root forms. We talked about reducing our feature space before. This is really helpful for that. It's state-of-the-art way to reduce those words down using spaCy, supports multiple languages, which is great. And then if you want to do some deeper, more grammatical analysis, you can use the spaCy morphologizer node, which is going to let you look at things like tense of verbs, cases, plurality is something singular or plural. You can really do a deep dive using this node. Again, all of these are backed under the hood using the spaCy library and allow you to do some things that you couldn't do before using Knime nodes. So I mentioned the limitization now supported in multiple languages, not just English. That really opens a wide door to allow you to do new things using text processing in Knime. You could do multi-label classification in Knime now where you couldn't before. If you really want to get sophisticated, you can do some things like sarcasm detection using these pre-trained BERT models. And just overall, when you're looking at classification results using a model, BERT is state of the art. It performs a lot better than the existing word2vec and doc2vec approaches that we've had in Knime. So all of these nodes and these extensions coming in are really adding some new capabilities that are going to allow you to do some interesting new things. But I think that's enough for me, kind of setting the table and laying out where we're going to go. I really want you to hear from our speakers today who are going to go into this in a little bit more detail. So I want to bring on Pertu now so he can talk to you about exactly what he's been doing, their use case, and the success that they've had there. Pertu, you want to take it from here?
Thank you very much, Scott. Yes, happy to. So very quickly, first of all, what do we care about as financial supervisors? So we are civil servants. So ultimately, we work on behalf of the public, members of the public, as well as the society as a whole. And some ways we do this. First of all, we care about the financial strength of financial institutions working within our jurisdiction. And this means, for example, that we make sure that they only take risks they can manage, so that the people who invest money into the institutions or otherwise customers wouldn't lose money in the process. We look after, we care about the financial institutions not being used for money laundering, for instance, terrorist financing. And then ultimately also we care about the whole system. Financial stability is very important because big things can go wrong in such an impact that the whole financial system will collapse, or small things that can go wrong at the same time in smaller institutions or smaller or different parts of the system. It can still bring the whole system down. So we really are keen to look after the whole sector as well as individual institutions so that everyone gets a fair deal. So therefore, it's quite easy to see that we essentially need to have our ears and eyes everywhere. The traditional means, of course, are that people read news and follow newsletters and so on. But what we need to do and what we want to do, because we are now is 2022 and we want to turn this into more real time and really use the capabilities machine learning can bring to us in spotting the news that matter to us and bringing them to us automatically. So things we care about, for example, here are, of course, the entities we supervise, the individual firms we supervise. But often in here, these firms already are subsidiaries of institutions abroad. So we, of course, are also interested to know what happens there. We then are interested about the peer groups, the other firms that have a similar business model than ours, or the peers of the parent firms. We care about the product areas, the businesses, type of businesses our firms are active in, and if not globally, at least regionally, what's happening there. We also, this is all, of course, all links to the real economy, and therefore we need to have a good understanding of what's going on at the macro level, not only locally here, but also regionally and globally. And then finally, I would say we want to also stay abreast of what the other regulators do. Are there regulatory announcements, events, new rules, etc.? We would like to be informed by these as much real time as possible. So how do you do this? The traditional approach, of course, is that people come in, they read the Financial Times, they watch their morning news, they might subscribe into some newsletters, and they get these into their emails, and then just trusting that everyone will eventually be exposed to exactly the stuff they need to be exposed to. But of course, we know it's not timely and it's not going to be precise. You will end up reading more than you need, and you will miss stories that you should have seen. The next option is that we subscribe into a service, media monitoring service. We tell a company that these are the types of things we like to see news about, and then they will tailor a system that will send us a list of links every day. But the problem here can be that this can be, first of all, quite costly. It can be thousands of dollars every month. And then also that would take the control of the underlying algorithm away from us. And this is important in a couple of ways. First of all, this is going to be probably more or less static. You might give the firm a list of keywords. These are the topics we are interested of, and they get fed into their system. But then it's probably going to stay like that. There are events like shock events like COVID a couple of years ago. No one knew that we need to enter a completely new search term into the system to cover the things we care about. So it might not be that smooth to go about it when you have a relationship with a third party like that, as to how do you ensure that the news service stays relevant over time. And then something I don't like is that we give away if we indeed were helping them to not just giving them keywords, but actually giving them labels or keep providing them more deep insight as to what we want to see, that's actually our property, and we don't necessarily want to share this with everyone else. And the third option is that we build something by ourselves. And of course, anyone having Knime disposable knows what the answer is. So the next challenge is how to access the news flow. There's loads of websites, there's loads of articles, news floating all the time. We could go and list the websites, the publishers we think we get the think that matter to us, and then start scraping them. We could maybe, if they have RSS feeds, we could use that. That's an easy way. But this would still be limited. We would be limited to that list we come up with, so we could miss some. And also, it would be out of date the moment we put it out, because we would need to put also effort in continuous maintaining of the list. But maybe this is something we shouldn't be doing by ourselves. And indeed, there's services such as Newscatcher, which has an API for rather small sum a month. You will get access to 1 million and more news articles every day across 60,000 sources, which means that we don't need to worry about this phase of the process. But the problem is still, or the challenge is still, which ones of those 1 million are relevant to us? So we thought we are clever. We use Knime already in here. We put a number of our historical or over time, reports we have written in-house over time, and we extracted n-grams from them using Knime. So we thought, surely if we use 2 or 3 word phrases against the API, we will get really precise results, because you can't just get false positives any longer. But even though we do this, what happens is that we still have roughly about half of the articles we receive are irrelevant. And they can be irrelevant in many ways. Either the scope is not right. Maybe the search term captures exactly the right type of articles, but if this is a small village savings bank in my native Finland, we don't really probably care about that too much in here. Maybe it is still possible that this phrase is just simply used in completely another context. Or sometimes these articles or blog posts that are covered, maybe they are just too opinionated for us to really consider. And I should actually add another one in here, which is that supervision is not about day trading. So, and there's loads of articles about stock prices, for example, which are daily, and they will comment every move. And you know how these headlines often are. They are like watching a ping pong match, that today the stocks that go up by 2% because of da-da-da-da-da. Next day, the same story might be used to explain why they go down by 2%. This is too timely for us. And that's just noise. That's not giving our supervisors anything. So that's another type of article we actually want to clean out and remove as part of this about 50%. So the good news is, and again, because we have Knime, we know how to go about this. So how about we use crowdsourcing? How about we take all of our supervisors and collectively label enough news articles so that we form, first of all, a good corporate view of what we care about. And if we collect enough of these labels, maybe we can even start doing differentiated services to different teams or even individuals, depending on their specific interests. So yes, this should be possible in principle. So what did we do? We built an app running on our Knime server, on which we have pre-populated the app with about 50,000 news articles over a couple of months, using those 800 phrases I told you about. And in here, then, our supervisors can go and either use keywords or even sentences or paragraphs to find news they are interested about. Or they can just choose to do 60 articles, which I'm going to do now. And then they will be presented with a bunch of articles in the labeling view of Knime. And simply, they look at the news. And is this kind of an article I would like to see as part of my daily headlines? Maybe not. Maybe not. Maybe not. Maybe not. That may be yes. And keep on going as long as they want. We provide these to our supervisors in units of 60 articles at the moment, thinking that this is a number that is not too much, but we still get already enough views in every round. And then we have also gamified this a little bit so that every week there's an email that will tell everyone where they stand in the labeling effort for the whole organization. That, for example, that you are currently the third labeler, you have labeled this many, and there's only 200 articles to label to reach the next person up. This is the very first time we try anything like this. And just the other day, was it yesterday, someone came to me and said, I'm the second. So we are getting somewhere, I think. So basically, that's about that. Now, I would be happy to hand it over to Artem to show how then the new text mining nodes help us to model the actual predictive model based on the labels we create.
Yep, that's exactly what we're going to do next. And thank you, Hartu, for showing the data app. I always enjoy seeing like live actual uses of the data app, so that we can see how people are using the product for real, right? And how simple and straightforward it is. Yeah, let's shift gears. We'll have Pertu come back at the end when we do a little bit of Q&A. Let me go ahead and invite Artem in. Artem, I guess you're going to show us a live demo with some of these nodes that I mentioned earlier, and we can see how these are working under the hood in the analytics platform, right?
Yeah, exactly. And actually, I'm also going to use the data that was obtained by QFCRA experts that Pertu has just described. So first of all, the nodes are split into two extensions, BERT nodes and NLP nodes, as Scott mentioned this. And during today's demo, we are going to cover more than half of them. For the rest of them, you can look for some other workflows that are available on Hub, just using, I don't know, text analysis or Redfield tags. Okay, let's jump to the demo. So today's data set is the news articles that have been labeled by QFCRA experts. Basically, the data set is quite simple. This is just the article ID, the article itself, just the plain text as it is, and the class column, so relevance class. So 1 stands for relevant, 0 stands for irrelevant. And also we have a second data set that has almost the same structure. The only thing is that those articles are not labeled, but it's pretty much the same. So it's just 2 columns. In the beginning, we are going to utilize spaCy nodes for 2 tasks. So the first task is to make some general NLP or classical NLP analysis using the whole corpus of the text, just to identify what are the most important terms, and so on. So these things that we are going to start with is just to read those CSV files and concatenate them together. The next step is to take spaCy model that we are going to work with. So there is a node called spaCy model selector, and as you can see here, everything you have to do is just to find your language, find the appropriate size of the model that you would like to use, and that's it. As you can see, there are multiple languages supported, about 20 as far as I remember. So you can just pick one of them and start using. So the model itself already includes everything you need in order to use some other spaCy nodes, let's say tokenization, lemmatization, morphology, vectorization, and so on. So if the model itself contains everything, you can use it. So unless you'll get some warning message. But most of the models, they are pretty much condensed. So they include everything you need. So I'm going to use NCore Web MD model. MD stands for medium. So this is a kind of a standard model. And then I'm going to use keyword search. This is the component that actually I took from this blog post, and I really recommend everyone to read it, Semantic Keyword Search for SEO. I just refined these components and included some spaCy nodes inside. So previously there were just standard Knime text processing nodes included. So let's see what's inside. So first of all, this component is configurable. It has a dialogues where you can, let's say, select the number of topics for topic modeling, number of words per topic modeling, some other parameters, let's say for IDF. So here comes very simple processing, but the first things first is that we need to take the text as a string, as we have it in our input table, and convert it to document format. So I guess those of you who are already familiar with Knime text processing node, you know that if you would like to apply some text processing nodes, you need to convert it to native Knime document format. And as Scott previously mentioned, spaCy tokenizer can be considered as kind of an alternative to string to document node. So the settings are quite straightforward. You just need to feed in the model and the table. So you need to select the column that contains the text that you would like to convert to the document. And that's pretty much it. So if you would like to, you can replace the existing column. So basically convert string to document, or you can add the document as an extra column. All right, so once it's done, the text is basically converted to documents. So this is how it looks like in Knime table, but you cannot take a look at the document in the Knime table, but there are some nodes, such as document viewer node, that allows you to investigate the node. The next step is to do some pre-processing. So there is an extra component that does this thing. Let's jump in and see what's going on there. The next quite standard step in classic NLP is to assign part of speech tags. So let's say adjectives, nouns, pronouns, adverbs, and so on. This is what this node does. So again, the settings are pretty straightforward and very similar to some other native Knime text processing nodes. So you select the column with the document, and then you select the mode, whether you replacing the existing column or adding a new one. All right, then again, we do standard procedure like punctuation erasure, number erasure, filtering the stop words that are not meaningful. Let's say words in English like a and the articles, they don't have any meaning at all. Just they are used for grammar purpose. We make a case conversion, and then we only keep the words, the part of speeches that usually keep the main meaning of the text. So we are only going to keep nouns, adjectives, and verbs. So these nodes now supports dynamic tags, and thanks Knime team that they helped us to make that happen. So let's say this particular model has its own set of tags, and this is fine. Now Knime can automatically fetch it, and if you want, you can just pick those tags, and then you can see the list here. So we are only going to keep adjectives, everything that starts with J in this notation, nouns starts with N, and verbs starts with V in this notation. Then we do some quotation marks replacement. Then comes lemmatization step. So Scott previously mentioned that lemmatization brings the word into its root form. So let's say if it was a past tense verb, then it becomes present tense verb. If it was a, let's say, a plural noun, it becomes a singular noun, and so on. One may say, okay, we had a lemmatization node in Knime before. True, but only for English. Now, as long as you have this set of languages, most language models in spaCy, they have its own lemmatization model, so you can use lemmatization for any language that is supported by spaCy. The final steps, we again do some stuff such as removing quotations and some extra spaces, and also we are deleting the very short words. So the minimum required length of the word should be 3. And then we are going to use spaCy vectorizer in order to convert the text into the vector. So again, the settings quite straightforward. I just wanted to emphasize that you are free to go whether you would like to feed in the string as it is or a process document. So it gives you flexibility. If you want to vectorize raw text, you can do so, and I'm going to do this. If you would like to vectorize the process text, you're free to go. Just select the document. This is it. So the next step is that we are just feeding in these process documents to nodes that you may have recognized already if you have been working with text processing extension. So we are going to do topic modeling with LDA algorithm. We are going to run term co-occurrence, and we also going to define the term importance by calculating term frequency multiplied by inverse document frequency. So this is a quite standard metric for defining the term importance. So then I prepared this dashboard also based on this blog post. So let's see what we have. So first, we have the top 10 terms estimated by the weight, by the weight of these words by topic modeling. So no surprise, most of them are dedicated to financial area like bank, markets, company, stock, and so on. But at the same time, let's say you can see the term importance. So bank and market are the most significant words. Then we have a tech cloud based on TF IDF. So let's say here we can see that follow and unfollow seem to be the most important verbs in that case. Also, we can see some country names like Iran and some company names, I believe. Yeah. In this text. So it also gives us some perspective or the scope of the corpus that we have. And another nice feature is that we can get the co-occurrence of the words. So this is actually quite interesting because here we have two separate graph components. They are isolated from each other. So let's say the first component is something dedicated to bank. So this node in the middle, and you can see it has the highest degree. So definitely this is something dedicated to bank. And the second graph component, isolated component that we have is something about the shares. So roughly speaking, we can probably split the whole corpus into two big clusters. One is dedicated to bank and probably bank policies, and another one is probably dedicated to stock market. All right. So once we have once we have understood the scope of our text, we can move to the classification problem. So previously, I have shown you that we have a labeled data set with a relevance class and unlabeled data set. So we are going to train two models, XGBoost and BERT model, in order to classify, in order to label the text. So previously, I have shown you that we have been using spaCy vectorizer in order to convert the text into the vector. So then this vector can be used as the input to any kind of algorithm. For this purpose, I'm just going to use XGBoost, but of course you are free to go with any other algorithm, KNN or random forest or any other you prefer. Just for visualization and simplicity, I'm going to color the table so we can distinguish the samples that are irrelevant blue and relevant red. Then I'm going to unwind the vectors because the vector is a special type of column in Knime. So it's a list, it's a collection, but in order to feed it into the algorithm, so this is how it looks like. This is a collection. Then I'm going to unwind it to put all vector components into a separate column. So this is just technical details. And then we do standard procedure for supervised machine learning for classification. I'm going to split up the test set and training data set in the ratio 80 to 20%. And then I'm going to use all those vector components as the input in order to train the model that will define the relevance class of the article. So I'm not feeding in the text, I'm feeding in the vector in order to train this model. And here I'm using two predictors, one for test data set, another one for unlabeled data set. And then I prepared a dashboard that shows the output. So first of all, on top, we have this model metrics. So we have a confusion matrix, we have class statistics, and we have overall statistics for the model. So in this case, we achieved about 75% accuracy, while F1 measure for the classes is about 71, 78%, depending on the class. If you want to, let's say, play around and pick some probability thresholds, according to your needs, you can use this binary inspector. Binary classification inspector. So let's say if you would like to take the maximum accuracy, it suggests you to have the threshold equal to 0.4. And then we have two tables that basically represent the snippets of these articles, along with ground truth for label data set, predictions, and class probabilities. And then you can, of course, just move and see the whole data set. Similar table is available for unlabeled data set. Technically now it is labeled, but it's labeled by the model. So apparently we don't have ground truth label here. We have only predicted value. So let's see how BERT does solve this task. So in general, as long as BERT is a deep neural network model, in most cases they are supposed to be better. They will give you the better accuracy, the better, let's say, F1 score. However, they are more heavy, so they might require some special, let's say, hardware, GPU in this particular case to run. So let's just find out how BERT did on this task. So again, we do the same split for training and test set. We have another special split for validation data set, so we can track how the model is being trained in order to, let's say, avoid overfitting. So the BERT model selector, it's quite similar to spaCy model selector. So we have two main options. You can pick a model from TensorFlow Hub or Hugging Face. Just take one of them. Some of them are dedicated to certain languages. You can just check, or otherwise you can try out some Hugging Face models this way. So you have to go to Advanced tab, click on this checkbox, and then you are free to go with a remote URL. So let's say you can use some other repositories. Once the model is selected, then we need to configure the BERT classification learner. So let's go through its settings. So again, similar to any learner node, these nodes contains the following settings. So first of all, you need to provide the inputs, so the features. And in that case, it's just one feature. It's the column with the text. That's it. And the class column, of course. It's, in our case, it's a relevance class. Also, another quite important parameter is the maximum sequence length. Basically, this is the number of tokens, which are, roughly speaking, words that are going to be considered in the text in order to make the prediction. Another feature that is out of scope for today's presentation is that you can use multi-label classification if you would like to assign more than one topic. But there is another example on Hub available. And in advanced topics, in advanced settings, you can just select the optimizer and provide the settings for training process, number of epochs, batch size, and so on. And another important checkbox is to fine-tune the BERT. So if you activate it, then training process will affect the whole BERT model. So the BERT model weights will be updated, not just a small classifier on top of BERT. It will definitely increase the training time, but at the same time, it will most likely give you the best results. All right, so I have trained for 3 epochs, and then I applied the trained model, fine-tuned model, to the following node. So I'm going to extract embeddings from training data set, similar that I have done here in this component for using spaCy vectorizer node. So then I'm going to shrink the dimensions and plot it, just to see, let's say, how the samples can be distinguished in this vector space. Sometimes it might be useful, or let's say you can also use the BERT embeddings for another algorithm to train a classification model. Let's say if you would like to save some, I don't know, money or time on GPU. So for example, you extract the embeddings and then you use something like XGBoost in order to train a model that will be trained faster and will run faster. And then, similar to the previous case, I'm going to apply trained model on test set and unlabeled articles. I have prepared very similar components that shows the output, the output of the model. So again, we have this statistics, and now we have roughly 79% accuracy. But what is more important, we definitely have better results based for F1 measure, which definitely says that BERT model is a way better. But at the same time, the training took way longer. Again, you can pick the probability thresholds by this binary classification inspector. Let's say if you are looking for the best accuracy or any other metric that you prefer. There are some tables with assigned labels for unlabeled dataset and labeled dataset, so you can check it manually. And also, I created this embedding visualization. And as you can see, it's not that straightforward actually to identify which topics, which articles are relevant and which are not. So probably, let's say if we look from this point of view, we can see that most of the blue ones, they are slightly on the left, while most of the red ones slightly on the right. It actually doesn't really help. It doesn't really help a lot, but still, probably if we would train the model even a bit longer, they would divide into more stable clusters. Hard to say, but in any case, as actually Perto mentioned that, what is the criteria when you define whether the paper is relevant or not relevant? Still, BERT and the spaCy can help you with automatic labeling, but at the same time, it's a hard task even for a human. So this is the end of the demo, and I just wanted to tell you that this workflow is already available on Knime Hub. So if you are interested, please go ahead, just type in news relevance webinar, and you can get it and test it out, the same data and the same parameters that I used. And just a small note for Windows users, there might be a problem with installation, which I hope will be fixed in next 9 releases, but still there is a solution for it, and it is included here in the description. So please follow it in case you have the problem with installation. Thank you.
All right, thank you, Artem. I really enjoyed seeing the deep dive into the new nodes and how we can configure them. I like that 3D image at the end. That was picture all the neurons in my brain firing off as I'm trying to understand all the new possibilities here with these new nodes. So thank you again. I want to go ahead and bring Pertu back in, so we have a few moments for Q&A. I know you guys have been firing off some questions at us as we go. Let me pull some of those up and ask our experts here. I think the first one I wanted to ask is going to be for Pertu. How do you deal, going back to your labeling application, how do you deal with differing opinions from the labelers when that comes up?
So this is a good question. And this is actually something really interesting for us to, first of all, to start to analyze this. Analyze how consistent people are over time. We actually, you saw I was I was choosing show me any 60 articles, but actually we are not showing just any 60 articles. There's a random element, but we are also showing you articles others have labeled before, but we are also showing you some articles you labeled before. So this is already interesting for us to start to see that how consistent people are, and then after that, how consistent they are across the teams. So our current solution is that for articles the same person has labeled more than once, we take the latest opinion as the current opinion. And then we simply take the mode of the opinions when there are multiple people having labeled the same article. And the more we get these labels, like I said, we hopefully start to understand the differences between teams, so that we can actually start looking into different models that maybe have the same base, but then differentiate based on the interests and the topics that team is dealing with.
Okay, so conflict resolution through machine learning. Okay.
Yes.
Let me ask this question to Artem. if you were going to visualize those spaCy tags, how would you do that?
Yeah, it's a good question. I think I can even show it if you could please get back the demonstration of my screen. So yeah, there is a couple of nodes, I guess. Yeah, but I would recommend you to use this text document viewer. Let me just think where. Okay, it comes. So once you have the documents, yep, you can just, let's say, use this tagged document viewer node. So you select the appropriate document column, and then you can open the visualization. So as long as I have, okay, it's okay. Let me just connect it directly to these nodes, POS tagger. Yeah. Okay. So once you have done any tagging like NER or POS tagging or morphology tagging, it should be already available in this tagged document view. So here they are. So probably it's too small, but yeah, let's say coverage is a noun, has is a verb, already is an adverb, been is a verb, and so on. So this is how it works. And again, you can use, let's say, tag filter in order to get rid of some tags or leave just this particular set of tags that you would like to work with.
Excellent. It seems pretty straightforward. I've used the tag document viewer node myself before, and it generally does what it says on the tin, right? It lights up like a Christmas tree if you've got a whole bunch of tags involved there. Yeah, exactly. Okay, thank you. Let me ask here. This question is, and I hope I don't pronounce your name wrong. I probably will. From Najmi, and it's for Artem. Do we need to remove punctuation marks when vectorizing using BERT, or do the punctuation marks help us contextualize those word embeddings better?
Well, in general, the BERT like philosophy means that you don't have to do anything with text. And in general, dots, let's say, they have meaning because they are encoded as a special kind of tokens. So this is a separator of the sentence. So no, if you are going to take BERT model, so I guess you don't have to do anything with text.
It just should work. Okay.
Yeah.
Fair enough. I think it's a really good question. Let me ask another one. This is from Abhinav, and I want to ask it to pair to. Going back to the labeling app again that you showed us with the data app in the web portal, is this already built? Does it already come with Knime, or is it accessible some other way?
So this uses the Knime nodes and components that are available from the hub. So the labeling view you saw is mostly done by one single node, which is called labeling node, I think. And there is a workflow behind it where we choose the articles, and then we provide people the search opportunity, and then we do the labeling, and in the end we save the labels into a database table. This is, by the way, something I will be putting also on the hub. So not in the complexity we use internally, but I will create a simplified version where you can already try out the similar functionality and download it the same way as the prediction workflow.
Great. So it sounds like that's coming. And eventually when it's available, it'll be available on the hub. For those of you who aren't familiar with the hub, hub.knime.com is where you can go to get example workflows for all sorts of use cases. But in particular for these, we'll post some of these so that you can play around with them as well. Let's do one more question here before we wrap, because I know we're getting close to the top of the hour. This question is from Tosin. I know I'm saying the name right because I know Tosin. Hi. These new Redfield BERT nodes, are they available on older versions of Knime or just the 4.6 version, Artem?
Well, as long as it was kind of a long story. So the first time those nodes, they were introduced, I guess, a year ago. So some of them, let's say BERT nodes just for classification are available for Knime 4.4, I believe. But the latest nodes, let's say spaCy nodes and BERT embedder node and BERT multi-label classification option, they are available for Knime 4.6.
Okay, fair enough. So it's spread out a little bit, but most of the new functionality is going to be available in 4.6, right?
Exactly.
Okay. Great. Well, with that, since again we're running close to out of time, I wanted to thank our speakers again very much for showing us what you're doing, how these apps work under the hood. It's really great to see people who know what they're doing demonstrate some really useful and interesting work or use cases for the rest of us. So thank you, Pertu, and thank you, Artem, for your time. I really appreciate that.
Thanks very much.
Thank you.
All right. And one last thing before we go today, I just wanted to make sure that I encourage all of you who are still with us, hopefully everyone, to register if you can for the Knime Fall Summit that's coming up November 14th through 16th. We've even put a handy button here in Hopin so that you can click on it and go directly to the registration page. We'll have some of the events streamed online, but we will also be live in Austin, Texas. Many of our folks will be there. I myself will be there teaching some courses and workshops. Come out and join us. You'll be able to hear live from our customers, people who are using Knime in industry, see exactly what they're doing, how they're using Knime, be able to talk to some of our developers, get your questions answered, and just hang out with other folks who are using Knime. It's always a good way to network and do that. So we'd love it if you can come join us again, November 14th through 16th in Austin, Texas. Click that button and come join us. With that, I just want to wrap up the webinar. Thanks everybody for joining us. Hope you learned something. I certainly did. And we'll see you at the next Knime webinar or event. Okay? Thanks everybody. Bye.